Good afternoon. My name is Mrs. Silvestre and I'm going to be completing the Year 12 Introduction and Induction to Geography by NIA. So this is me. I'm a total geography geek and I love to understand how the world works around me, and I love knowing how places connect and the reasons behind why things happen. I'm really passionate about our planet and what we're doing and the impact we have on it. Plus there's some really good geographers out there. Love a bit of David Attenborough. So these are the members of our team. This is Miss Eek. She is very passionate about geography also, and she loves where people live and what the land is like and the features, and she likes to be able to walk around the world and understand why the way it is. Meet Mr. Jones. He likes volcanoes. He has a particular notion in the idea of transcending borders and wealth and acquisition of wealth and humanity and such like. This is Mr. Flaherty. He's a new member of our team and he likes enjoying sharing the world and helping students discover what it's like, the way they live, the world they live in. And our other newest member of our team, Mrs. Sheridan, and she loves the world around as well. So there's a common theme developing here, isn't there? So why study geography? Geography is one of the most employable university graduation course. You have a multiple skill set, you're able to work in teams independently, report writing from doing your field work, a multitude of different interpersonal skills with other people, and I've put some clips on this slideshow that is available to you for you to have a look at as well. So the course is split into 3 different parts. Component 1, which is the physical geography written paper. This is worth 40% of the course. The test paper is 2.5 hours long, and there are 3 sections on it. The areas that we will be studying are water and carbon cycles in section A, coastal systems and coastal landscapes in section B, and hazards in section C. Then on to component 2, which is human geography written paper, which is also worth 40% and 2.5 hours long. Once again, it's divided into 3 parts of the paper: global systems and governance, part A; section B, changing places; and section C, population and the environment. The last part, component 3, is geographical and investigation, the non-exam assessed part of the paper. This is where you write a field report between 3,000 and 4,000 words long, and it's moderated firstly by your teacher and then moderated by AQA later on. So let's have a little look at those sections. In the physical geography section, you'll, like I say, look at 3 different parts. Water and carbon cycles, where you will learn about water and carbon cycles, obviously, to start with, and how these are closed systems and how they interrelate the two. You'll also look at case studies like the River Tweed and the Amazon rainforest and how that works, and how the water and carbon cycle are affected and how we're having an impact on them. Another one of the sections you look at is coastal system, coastal landscape. Now, most people have looked at coast before. Obviously, we'll be looking at it in much more depth. We'll be looking at the inputs and the outputs of the system, looking at case studies in the UK and the wider world. And we'll also looking at our impacts that we're having on it. And coastal systems over a different period of time, a shorter period of time, ranging to a much longer period of time. We look at things like isostatic and eustatic change. The last section of this paper we'll be looking at is hazards. Okay, and hazards, we'll be looking at a range of different kinds of hazards. We'll be looking at what a hazard is, what's the difference between a hazard and disaster. We'll be looking at wildfires, flooding, and we'll also look at volcanoes and earthquakes and all the other things that go with that. We'll also look at various different case studies and comparisons between them and the landforms and features that are created by these hazards. Paper 2. First part we'll be looking at is global systems, global governments. This has how different countries relate with each other. So things like trading blocks and globalization. And we'll also be looking at things like global commons. So where that is, and Antarctica will be a particular case study. We'll look at that. In the next unit, we'll look at changing places. So that is sort of exactly what it says on tin, basically. It's looking at how different landscapes, different urban landscapes change over time. We'll look at 2 case studies. We have to look at a local case study and a faraway case study. So the local case study we'll look at in Northampton, and the faraway case study we'll be looking at Stratford in London. We'll look at how those places have changed over time and how people feel about those places. The last unit we're looking at is population and the environment. Within this, you look at a multitude of things. You look at things to do with how the landscape is around us, the different climate of those regions, the farming and agriculture that goes on there, and how people use them. We also look at population and how that interrelates with the environment. So that's sort of very up to date. And we'll look at case studies as we go along as well. The last part, the NEA. This means that you have 4 days of fieldwork that you have to do over the 2 years. We will take you on field trips throughout the 2 years that will interrelate with different components of the course. So you can have a look at things like sense of place, for changing places. You can do some river studies. We can look at globalization through TNCs. And through the NEA, you create your own hypothesis and carry out an investigation to either prove or disprove it. It's a between 3,000 and 4,000 geographical reports. And in that, you're expected to come up with some questions about anything to do with the specification you've looked at. So, for example, you might want to look at the difference between how constructive and destructive beaches are and the waves that affect them. Maybe you want to look at the sense of place of a location you've been to. Or maybe you would like to look at how a place is particularly changed by some kind of impact that's currently going on. Maybe there's a new road network being created or railway network created, and the impact of those things. So, throughout the course, you'll be assessed on 3 different assessment objectives. The first one, you'll be expected to demonstrate your knowledge and understanding of places, environments, concepts, processes, interaction and change, and at a variety of scales. So what do you know about places? What are they like? What concepts do you understand? AO2, applying your knowledge and understanding different contexts to interpret, analyse and evaluate geographic information and issues. So through AO2, you will learn how to apply your knowledge. So you'll look at sources and tables and data, and you will apply what you've learned in AO1 to that, and also look at how you can evaluate your case studies and how do they support the knowledge you've learned. AO3 is looking at a variety of quantitative, qualitative and fieldwork skills. So you will be interrogating data and coming up with some evaluation and evidence, constructing arguments, and drawing conclusions from the information that you've learned. How this really works practically is that it means that on the exam paper, you have different styles of questions. You have 4-mark knowledge questions where you're asked to come up with and explain an idea or a concept. 6-mark questions which are data response ones or related to sources, where you'll be given a graph or a map or a graphic of some kind that you'll be asked a question about. 9-mark short essay questions and 20-mark extended essay questions, where you will be given a much more broader statement that you will be expected to comment and sometimes suggest to what extent you think you agree or disagree with something. So, for example, maybe you might have to talk about how Thomas Malthus's theories aren't relevant anymore today, and Simon Brosrup is much more involved. So what we recommend that you do before you take a course is, over the summer, that you spend a bit of time looking at things that interest you. So to give you a good firm background, think about making sure that you watch the news and you print off news articles and reports that are going to help you with your studies. Now, to know which areas particularly and to look at more depth what you will learn in each of their areas, a good place to start is looking at specification. I'll put a link on this PowerPoint for you to click onto, so you can go onto the AQA website and you can look at the specification there. You can look at each part, so you know what kind of things you're looking for. Another good thing that you could perhaps do is watch geography-based TED seminars if you haven't watched any before. These are particularly interesting. They're done by people like myself, very different ideas. I've put on here a couple of links to give you some ideas of where to get started, but there's lots more. Okay, so on to the second part of our lesson today. I'm going to give you an induction lesson to do with coast. Okay, so in the coast scheme of work, where you usually start off is by looking at the coastline and how it's the system works. And then you look at inputs and outputs and whether it's a closed or open system. And then you move on to look at where energy comes from in the coastal system. So our objectives are to know what inputs there are at the coast, to be able to describe how waves and tides are formed, and to be able to explain how waves and tides impact upon the coastline. Okay, so this is the coastal zone, and it's divided into three sections. The foreshore, inshore, 4 sections even, offshore and nearshore. And within that, you have the swash zone and the surf zone. So basically what this means is that when we're looking at the coastline, we're looking what the interaction is between these areas. So how do the waves and the material that's there impact on what's going on? As you can see on the diagram on the right, which is really clear, that the offshore is the area that is furthest away from the coastline, where the waves are coming in. And then you have the breaker zone, where the waves are starting to break down and their energy is having some impact. The surf zone, where the waves are impacting along the nearshore. And lastly, the swash zone, which is where the waves are coming in. The swash, remember, is the waves coming up the beach. Okay, so sources of energy at the coastline. So impacts act upon the control factors such as lithology, so that's the landscape itself. The structure and the geology, so what are the rocks like? Are they hard rocks? Are they soft rocks? How are they aligned towards the coastline? And the tide range, the difference between high and low tide. Depending on how much energy there is, depends on how much concentration of that energy, and therefore what kind of landforms are created. Okay. Inputs are transferred into the coastal zone from elsewhere, such as energy flows in the form of wind and wave energy. So what this means is that as the wind comes to the shore, depending on how strong it is or how long it's been blowing in a certain direction, depends on what kind of waves you have and what sort of energy they have, and therefore what kind of impact they have on the coastline itself, the rocks, the beach. Okay, and the combination of physical material and energy that looks at those main impacts. So let's move on and look at waves. So this is a diagram that shows oscillatory and translatory waves. And so basically what this means is the waves that are coming into the seashore. Now, waves don't really move anywhere. It's just an illusion. What really happens is the bottom of this ocean or the sea becomes steeper and less steep. And as that happens, what happens is the wave that once before was able to move around in a circle, in a molecular circle, like you can see in the left-hand side of the diagram, is unable to do so anymore. Okay, it's unable to go up and down. So what happens is it starts to break. The top of the wave starts to move quicker than the bottom of the wave. And then eventually you get breaking waves onto the shore. And depending on how much energy it has, depends on what happens next. Okay, so there's two different types of waves. There's what we call constructive waves and destructive waves. So constructive waves are the ones that add material to the beach, so they make the beach much bigger. And destructive waves are the ones that take material away, as you can see in this diagram. So what that really means is that constructive waves have a much stronger swash, and destructive waves have a much stronger backwash. The swash is the wave coming up the beach, and the backwash is the wave coming down the beach and taking material away. So this diagram, this table, shows what the characteristics are between the waves themselves. Okay, so on the left you have your constructive waves, and on the right you have the destructive waves. So the characteristics of the formations that create those two types of waves. So constructive waves have lots of energy, and they've been created in open water far, far away from land, and distant weather systems have made those waves. And as they've travelled over distance, they've got what we call a really big fetch. As they get to the landscape themselves, they're able to translate that information, that strength in the wave. These are low surging waves with long wavelengths, and they have a strong wash and a weak backwash. And this means that they're able to construct build up the beach. Okay? Usually they're associated with gentle beach profiles, although over time they can build up a beach that makes it much steeper. Okay, so what this means is it's the kind of beach that you go to, and at the back of the beach, it's really big and built up, but as you move towards the sea, it becomes much more gradual. Okay, the other type of wave, the destructive waves, are high plunging waves with a short wavelength, and they're created much more locally, and this means that they have a weak swash, so they don't move much energy, they don't have much energy when they run up to the beach. Okay, so they're not able to bring more material, lots more material onto the beach, but as they come back down the beach, they're much stronger and they take a lot more material away with them, and these build destructive beaches. Okay, so that means there's loss of material on them, and usually they're associated with really steep beach profiles, although over time they can flatten the beach out as well. Okay, so moving on, the next thing I want to think about is wave refraction. So what happens to the waves that come to the coastline that's not a nice long stretch of beach? What happens if they meet, say, a headland? Okay, so a headland, which you might remember from GCSE, is a piece of land that juts out, sticks out into the sea. And as the waves come into the sea, come in from the sea towards the land, towards the coast, parts of the wave will start to slow down. Okay, as you can see in the diagrams on this picture, there's a really good graphic at the bottom right there that shows the waves taking on the formation of the coast. So as they get to the headlands, they start to slow down either side of it. And this means that the waves are less concentrated and they are putting that energy only at certain points, really. Okay, and the most concentrated energy is at the headland, and as you move away from it, you can see the waves gradually get less energy. And once again, look at that picture on the bottom right-hand side of the PowerPoint. You can see the whiteness of the waves where they're breaking really closely to the headland, to that piece of land that's jutting out, and that means that's where most of the energy is going. And what this really means is that it explains the reason why you get those beaches in headland recessions. So this is why you get those caves forming and the archways forming, and then later on the stumps and stacks. Okay, another thing that we're going to think about, another input into the system, are tides. Okay, so the tides are the variations in sea levels. Okay, so this means when the sea level is at its lowest and the sea level is at its highest. These are created by the movement of the sun and the moon around the earth. Okay, so as you can see in that graphic there on the right hand side, as the Earth rotates, okay, it draws the tide, the waters with it. Okay, the strongest pull is when the moon is moving. Okay, and the weaker pull is when you're not in line with that. What this means is that basically when we have high tide in the UK, the countries on the east coast, the countries that are sort of on the opposite landscape to us, which are sort of the Netherlands and France and places like that, they have a low tide. Okay, usually in the UK we have 2 high tides a day and about 12 hours and 25 minutes apart. There's a relative difference between the high tide and the low tide, and this is called the inter-tidal range. So basically that's the area where most energy is being deposited. So what that really means is that's where most erosion is happening. Okay, and as you can see, there's a graphic there that shows it's a tide timetable for Chroma. And what we could do is we could create the intertidal range. So we could take away the difference between the high tide and the low tide, and then we'd know which part of the coastline is getting the most concentration and the most erosion, where the most erosion. Okay. So if there's a small tidal range, the power of the waves and therefore erosion is concentrated on relative narrow sections of the cliff. However, if there's a high tidal range, vast tracts of sand can be exposed at low tide. This is when sand dries out and onshore winds can transport the sand to form sand dunes. So basically what we're saying is that if we're looking at tides, the intertidal range is important to know about because it gives us a clue of what kind of landforms are going to be created, just like when we're talking about whether there's destructive and constructive waves. When we look at the intertidal range and pull those bits of data and information together, we can decide what kind of landforms and hypothesize what might happen to a piece of coastline in the future. So that leads us on to our next bit, our next idea, where we're going to look at high and low energy coastlines. So you've got 2 pictures there. The one on the left is a high energy coast, so you can see lots of erosions going on, and you can see how the cliff has been shaped. And on the right, you've got a low energy coast. Okay, so there's much more gentle slope for each profile, and different landforms are created in each one. Right, and this brings us towards the end of our lesson now. So I've given you some tasks to do that. If you have a look back through the PowerPoint at your leisure, and you will be should be able to do those tasks. The next slide has the information for Chroma much more larger, so it's manageable to look at for the intertidal range. And at the very last slide of the PowerPoint at the very end, there are some websites that you can also use to support yourselves. Well, I hope you've enjoyed your introduction to geography, and we look forward to seeing you in September. Thank you.